Yeah, being in this space, I know I gotta hold my hold down. Seeing what it takes, I gotta know that I can show. I'm questioning myself if I believe it though. No longer question.
Hello everyone, welcome to the show In Code We Trust. I'm your host, Paresh Masani from Token Metrics team. Quick introduction about myself. I have been working as a full stack developer for more than 10 years now. I'm very passionate about technology and love blockchain innovations. I'm ex-executive director at Goldman Sachs and also worked at Barclays, Thomson Reuters, and JP Morgan. So today I'm going to do a technical code review for Facebook Libra project. I will be going through the technology scorecard metrics that we use at Token Metrics to validate the technology strength of the project. Please note that I'm giving an unbiased technical review about Facebook Libra project only for Token Metrics platform. This is not financial advice. Always do your own research before making any decision. So let's start with the introduction of Libra. So Libra's mission says a simple global currency and financial infrastructure that empowers billions of people. So based on their white paper, they are trying to solve two major issues, right? The one is there are 1.7 billion adults globally remain outside of financial system with no access to traditional bank. The other issue is if payday loans can charge annualized interest rate of 400% or more, and the finance charges can be as high as $30 just to borrow $100. So basically, this blockchain and cryptocurrencies have a number of unique properties that can potentially address some of these problems, right? Mainly the accessibility and the trustworthiness. And we all know that existing blockchain systems have yet to reach mainstream adoption, right? And that's the reason most of projects are struggling to keep up in the market, right? And why we yet to reach at mainstream adoption? I think mainly two issues: the volatility and the lack of scalability. So I think the Facebook Libra is a giant step towards banking unbanked people with a lower cost, more accessible, and more connected global financial system. That's what I think, guys. All right. So what we will do now is let's go over some very important factors that we consider at Token Metrics for any project to validate the technology strength of the project, basically, right? So one of the things that we look at is, does the project need to use blockchain technology? So I would say yes, because Facebook Libra has its own blockchain. It's called Libra blockchain, right? And they have implemented their own state replication algorithm called Libra BFT, right? We will have a look at a little bit detail in this video. They have their own programming language called Move, right, for implementing custom transaction logic and the smart contracts on the Libra blockchain. The second thing we want to see is, can this project be realized and feasible to implement? Absolutely, because when Libra project was announced, they had everything in testnet available for developers and ready to go. So in this video, I will also show you the Libra blockchain testnet demo, which is amazing. And next thing is, does anyone need this project? I would say yes. Billions of people around the world need this project for their day-to-day finance needs. Again, guys, this is my perspective. And the next thing is this project protected from commonly known attacks? So we will see this in a little bit detail about the Libra blockchain, the way the Libra BFT consensus protocol is implemented, right? Facebook has implemented this protocol such a way, they kept scalability and the security in mind as a top priority. Okay, and you can see Facebook Libra white paper and other technical documents are so detailed, explaining the whole ecosystem so clearly what they're trying to do. So I just want to, brief through the website, what they're trying to do. Let's see. So Libra, yeah, is for everyone. It will be available on the mobile. All you need is just a smartphone and the data connectivity, and it is accessible to anyone. It is going to be a stable coin, right? We will see what does that mean. It's going to be fast and available for the whole world. Scalable and security was the topmost priority when they were implementing the Libra blockchain. Right, so let's have a closer look at some of the things they mentioned here. So the Libra reserve, basically, this is what makes Libra coin as a stable coin. So if you want to have a look more detail about it, you can have a read through this paper. This is out of scope for this video. The Libra blockchain, we will have a look at a bit detail about Libra BFT algorithm. The Libra association, I think this is a quite nice thing. People see that the Libra blockchain is not decentralized. I mean, it is true. It's not fully decentralized, but they already mentioning that it is a permission the blockchain to start with, right? And you can see they have formed the Libra association to run the consensus node between these all parties associated. And the reason for that, I think they have done so that, they didn't want to keep everything for themselves, right? I mean, they didn't want to run the only single node for themselves, rather than they have splitted this responsibility across some of the very big dudes, all right? I think this can be something huge. But as we know, that there's a lot of opposition, right, happening from regulations, from government, and Libra is going through the tough time. I have my own opinion, so once we complete this technical review, I will be giving that what I think about what's going to happen and end of this video. Right, and then you can see they have security and privacy on the Libra network paper. Compliance also clearly mentioned, and this is very important, guys. So even though the Facebook Libra is permission to start with, they have a plan to move towards a permissionless consensus, right? And they have some challenges to overcome. We will see end of this video. What does that mean? They have this Move programming language to write smart contracts on Libra blockchain. They also have a technical document about the state machine replication, which is Libra BFT. We will have a look at in a little bit detail. All right, guys, so let's have a look at a state machine replication in the Libra blockchain. The algorithm they have implemented is called Libra BFT consensus. This Libra BFT consensus algorithm is based on hot stuff. So basically, that's how all nodes implement this protocol to maintain the replica of the blockchain. The Libra BFT has made some improvements on hot stuff protocol. Some of the key properties are like, first, Libra BFT maintains consistency among honest validators, even if up to 1/3 of the validators are corrupt. And the second is consistency is guaranteed even in cases of network asynchrony, which makes this algorithm even better, which prevents the denial of service like DOS attacks on the network. The third, that all transactions become irreversible committed to the blockchain. Fourth, the Libra BFT supports both linearity and responsiveness. Hot stuff protocol was not able to support these two desirable properties simultaneously. Basically, the linearity guarantees that commits incurs only in linear communication fashion, which is optimal solution between the nodes. And responsiveness means that the leader has no built-in delay and advances as soon as it collects responses from the validators. We are going to look at the validators in little bit detail very soon. And the fifth very important property is sustainability, I would say, right? So we know the current public blockchains consumes lot of amounts of energy because the trust depends on the computational power, right? In case of Libra BFT, which is designed as a proof of stake system and is incentivized reward to good behaviors and punish wrongdoings from stakeholders. So the computational cost in the Libra BFT consists of cryptographic signature, a standard concept basically, but with an efficient implementation. We're not going into very much detail about the Libra BFT and state replication algorithms. Otherwise, this video will go hours and hours. Right. So let's have a look at a very quick introduction to Libra protocol. So the heart of the Libra protocol is two fundamental concepts: transactions and stake. At any given point of time, the blockchain has a state, right? So executing a transaction changes the state of the blockchain, right? For example, this diagram, we have a state from S1 to Sn. Let's say on the state Sn minus 1, if we execute the transaction Tn, blockchain moves to Sn. So basically the state of the blockchain function depends on the previous state and the current transaction, right? So they have given this example: if A has 110 Libra, B has 52 Libra, the transaction is send 10 Libra from A to B. That basically changes the distributed version of this database, and the state of the blockchain, where A has 100 Libra and B has 62 Libra. And the important part and the thing that makes Libra blockchain different from all other blockchain is this: all of the data in Libra blockchain is stored in single version distributed database. What does that mean is the blockchain is represented as an ever-growing Merkle tree of transactions. So not like, the blocks. Blocks are there, but they stay in memory temporarily until it is committed, to the storage and persisted there on the blockchain. We will look at the validator, the node, and its logical components to understand this. So yeah, let's have a look at a node, validator node. So basically, the clients of the Libra blockchain creates transactions and submit it to the validator node, right? And these validator nodes decide which transaction will be added to the blockchain and in which order. These are the logical components of the validator. Admission control is an entry point to the validator node, so any request made by client to the validator node goes to the admission control first. It performs initial checks on the request, like duplication of requests, replace of the transaction, etc. Then the mempool is a buffer that holds the transaction that are waiting to be executed. And the consensus component is responsible for ordering the block of the transaction and agreeing on the results of execution. And the execution component utilizes the virtual machine to execute transactions. It maintains the in-memory representation of the result until consensus commit the block to the distributed database. Amazing architecture, guys. And this admission control and mempool, they both uses virtual machine component to perform validation checks on the transaction. So they have all these details, guys, here. If you want to have a look at more detail, please go through this. So the next thing, what we're going to do is testnet, Libra testnet demo. All right, guys, so let's have a look at the Libra testnet demo. I have already cloned the Libra core repository here, so you can see. It has all the logical components of validator, right? Mempool, storage, etc. I already ran the setup script, which is required to fetch the dependencies required for this Libra core, right? And what we're going to do now, just run the testnet client, right? So let's run. It's running. So basically now we have this Libra console. My local machine is connected to the Libra testnet, right? So now let's execute some of the function, right? So one of the thing is they have account create. So basically which creates the new account. Can create another account. So basically if the account is already created and persisted in the testnet blockchain, then it will retry. Otherwise it will create. That's what basically is saying. If we see the account list, you see there are two accounts has been already created or fetched. We will have a look at the sequence number why it is 2, because I already performed some of the transaction in this. So I mean you can keep creating as many accounts as you want, and you can see the account list, and it creates on the blockchain. You can see like two of these accounts are persisted, so which are already on the blockchain. This account is still in my local, right? So if I make any transaction, it will be persisted on the blockchain. So now let's do some mint. But first, let's query the balance. So query balance 0. So I already have like 0 account, right? Ending with F0 already has 100 Libra. Number 1 has 800 Libra, and number 2 has 0 Libra. Okay, so what I'm going to do is let's mint addition 100 Libra to the 0. So it's 100. Okay, so yeah, minted is done. So if I query again the account 0, I have 200 Libra now. Great. Right, so let's do some transfer now. If I want to do transfer, right, I can use the transfer command. So like this, transfer, let's say 100 Libra from account 0 to account 1. Right, so the query has been submitted. So you see like transfer has written immediately, right? But if you want to do like a block transfer, you can use transfer B. So basically it will return only when the transaction has been executed and confirmed on the blockchain. So let's do that. Yeah, so you see that yes. If this transaction has been confirmed, so let's see actually the transaction details. So you can run this command is suggested, and you can see true. I want to see the events as well, and you can see, yeah, the sequence number is 3, and the total the gas amount and the transaction, right? So it is sender is ending with F0, which is our account 0, and the receiver is ending with 50, which is our account 1, right? And the amount that we have sent is 100, but this amount is mentioned as a micro Libra, so basically is 10 to the power 6, so it's 100 times 10 to the power 6. Right, and you can see the events also that it logs here, like contract events, account event, right? Like basically it says the transaction happened from this address to the another address. Right, so I think that's pretty much it, guys. So if you want to see the balance, again, let's see that we can see the query balance 0, right? So you can see there is a 0 balance now because we have done the 2 times transaction, right? One was non-blocking transaction, transfer 100, and another was blocking transaction, means wait until the transaction has been confirmed on the blockchain. So the 0 account doesn't have any balance. The number 1 account has 1,000 now. It had initially 800, so it has received 200 more Libra from account 0. And we can check the sequence numbers as well, which is one of the important bits, right? So let's see the query sequence on the zero account. To do that, we execute this. So you see now the sequence number is 4. On the account 1, the sequence number is 0. The reason for that is sequence number only gets incremented from the sender. When you make the transaction, it gets implemented by basically. So there are 4 transactions happen from account 0 to account 1. So let's make one transaction. I'm just curious to see, like from 1 to 0, we send back, let's say, 500 Libra, right? And it's blocking. So let's see now the sequence number of 1 is 1. Perfect, right? And the sequence number of 0 is still the 4. And if you want to see the how much balance, the one has now 500, and it should 0 also should have the 500. Perfect. So this is it, basically the demo of the Libra testnet blockchain. Right, guys, the demo that I just showed you is based on this page, my first transaction. So if anyone wants to run it from the scratch, you can literally follow a step-by-step instruction. Right, so next let's have a look at the Libra code. So they have the Libra repository, right? And you can see there are like more than 11,000 stars, and the repository is already being forked like more than 1,600 times already. The code is already following the standard practices, right? Like they're using the Docker for installation of dependencies and the setup, which is my favorite way to do the things. They have a very good number of contributors, right? Like some of the top contributors coding very regularly. The whole code you can see is written in the Rust language and the JavaScript. Right, guys. So the last thing before my overall opinion I want to show is moving towards the permissionless consensus. So Facebook knows, if they want to, drive this Libra network to achieve its full potential, right? It has to be permissionless. Okay, and they are working on it. Like there are a lot of challenges to go permissionless. They have mentioned it here. We are not going over it, but you can have a look if you're interested. And one of the caution that you need to understand is Facebook has actually warns all investors that Libra digital currency may never see the light of day. Right? Maybe because of this government and regulation position. So the last thing I just want to say about what I think, what is my overall opinion about Libra blockchain project. I strongly believe in the project, and despite being Libra going through the government and regulators' objections at the moment, I think it will come into the mainstream with some changes. But this is, of course, my strong assumption. I can be totally wrong, right? We know as time flies away. So guys, this concludes this week's show. Thank you for watching In Code We Trust. Goodbye and take care.
Steve and Dave use eToro to invest in the financial markets. Steve does research on global investment opportunities. Dave does research on how to become a level 60 wizard. Steve follows the feed for the latest market news. Dave follows the feed for the latest cat videos. Steve has a watch list for promising investments. Dave has a watch list too. So why is Dave just as good an investor as Steve? It's because Dave used eToro's copy trader to automatically replicate Steve's trading activity. Whenever Steve makes a trade, Dave does too. Yes. Trade like a Steve with eToro, the world's leading social trading platform. This the only life I know. I believe it in my mind, so I know it's time to show.